Hello, in this video, let us look at how to sketch the graph of the three main trigonometric functions, the sine, cosine, and tangent. Yes, we can do it with a calculator, and we will in a minute. But first, let's just see where that picture comes from. We have looked at how to come up with the values of the sine and cosine and any other trigonometric function if the angle is any multiple of 30 degrees or 45. So 0 and all the way through. And we can do it for the positive angles going forward, counterclockwise. We can also do it for the negative angles going clockwise. So here is a table of a few values. Let's figure out what they are once again and plot them on the coordinate axis. Because it's a unit circle, the most it can ever be is 1 and -1. So our graph will bounce off between plus minus 1, and on the x-axis here we have the degrees. Positive in the positive direction, negative in the negative direction. So this is like scrolling through the circle in the counterclockwise direction, and this is going clockwise. So what is the angle? If the angle is 0 degrees, what is the value? Well, the value is going to be 0, because the sine of 0, the length is 0. So we plot 0. Next is 30 degrees. For the 30 degrees, we go to the sine and we measure the length. It is much closer to half, so that answer is half. We plot half. For the 60 degrees, we go to the sine and we ask ourselves, is this length closer to 1 or closer to half? It's much closer to 1, and so that answer is square root of 3 over 2, or 0.866. So almost 1, but not quite. But if we hit 90 degrees, then we are precisely at 1. So at 90 degrees, we are here. And so this is the curve that we are going to get. As we move on the other side, we repeat the same values. For the 120, we are we're closer to 1 than to half. So that answer is the same square root of 3 over 2, which is here. For the 150, we are here, and that's much closer to half than it is to a 1, so that answer is half. And for the 180, we'll be back here, which is 0. So here is the first half of the sine function. And then as we go to the further, we will get past 180, 210. Now we're in the negative territory, and we repeat the same exact values, so the graph will continue this way. Now on the negative side, if we roll this way, that's the negative angles, then the sine of -30 is once again -half, and so here's -half for the 30, and then for the -60 will be at almost -1. For the -90 we will be at 1, and I'm past my scale. So here let me remove some of these dots, make it a little clear. So at -30 we are at half, at -60 we are almost 1, and -1, and at -90 we are at -1. So here is the other piece, and again it'll continue this way, and will continue this way forever and ever and ever, because we can move through the circle as many times as we want. Once we go through 360 degrees, we can keep going and make this picture continue. So in a little bit, just a brief sketch, what it'll look like is a wave that just bounces off like this, over and over, forever. And it bounces off between plus minus 1. So here is the calculator version of it. Let's go to y, type in sine of x, and for the window we can choose the for the window for the zoom we can choose the 7, which is trigonometric window, and that'll make it the picture a little bit better to look at. So here is our sine function, and it looks pretty similar to this, much cleaner, but pretty similar. Now, if we wanted to restrict our window to from negative 360 to positive 360, so that we only looking at one rotation around the circle, positive direction and negative direction, then here is the sign. We can also do exactly the same procedure for the cosine. And for the cosine, here is the cosine. For the 0 degrees, the cosine is positive 1. So we start off at 0 degrees at 1. For the 30 degrees, the cosine is almost 1, which is square root of 3 over 2, or 0.866. So for 30, we are almost at 1. For the 60, we are much closer to the half than we are to the 1. So for the 60, the answer is half. And for the 90, if we are here, the value of the cosine is right between plus and minus 1, which is 0. So for the 60, we got half. For the 90, we got 0. And so we have the first piece of the curve. On the negative side, it will repeat exactly the same values and come out this way. To the negative 90, I'm sorry. It goes to the negative 90, it'll be at 0. And then the picture will continue as a wave in both directions, just like the cosine, just like the sine did. So here, with a calculator, let's have a look at that and get rid of the sine and put in the cosine. So here is the cosine. At 0, it crosses 1, and then it bounces off. Very similar to the sine, hitting the same plus minus 1 values, but in different angles. And then the final one is the tangent. Now for the tangent, we don't have the values. We can come up with them ourselves once again. But the thing to remember is that tangent is the ratio of sine divided by cosine. And so each time the cosine turns to 0, we are dividing by 0, and that makes it undefined. So where is cosine equal to 0? Well, here we can see that at 90 degrees it's 0, at negative 90 degrees it's 0, which means at that point our tangent is undefined. It's impossible. And then again it'll be 0 at 270 degrees, and so on. Now, that means that at these angles, positive 90, we have vertical asymptote. We cannot cross it, because if we did, we would be dividing by 0. At 270, once again, we have a vertical asymptote. At negative 90, we have vertical asymptote. But in the middle, the sine of 0 is 0, and so we are going through this point and getting closer and closer to our vertical asymptotes, like this. And we're going to go through 180, and then like this. So this is a graph of a tangent, and it continues like this forever and ever and ever. There is more vertical asymptotes, and I'll keep doing this indefinitely. These graphs are called periodic because they keep repeating themselves over and over and over forever. The period is the place where the graph repeats. So from this point to this point, it's exactly the same curve. So from here to here, this is one period. After that, the picture just continues. And that's why we call them periodic. So on the calculator, let's have a look and see if the tangent picture is correct. So here, let's clear, go to the tangent and hit the graph. So these are the vertical asymptotes. We do not see the vertical asymptotes, but they are there. That's why the picture breaks. So this is the graph of a tangent. So when we look at our textbook, sometimes we will see this version of a picture and not this version, but this version comes from the unit circle, and so do the rest of them. And this is it. That's how to sketch a basic graph of sine, cosine, and tangent using the unit circle. If you have any questions on anything, please let me know. Thanks for your time. Take care.